I'm Anil Kumar. Welcome to my series on limits and continuity. Here is an excellent question asked by one of our subscribers. We'll try to understand the concept of one-side limits and continuity with the help of this example. Consider the function g of x. It is a piecewise function. It is equal to x times absolute value of x minus 1 divided by x minus 1 when x is not equal to 1 and is equal to 0 at x equals to 1. Evaluate limit when x approaches 1 from the right side, that is the meaning of 1 plus, of g of x, and the limit when x approaches 1 from the left side, and then determine whether the limit at 1 exists or not, right? Part B is to sketch the graph of g of x and identify any points of discontinuity. Now, to answer this question, you have to first understand the absolute function x minus 1. The absolute function x minus 1 should always be treated as a piecewise function, right? So we'll first look into the absolute function x minus 1 and then get into the solution of the question. Absolute value of x minus 1 is written as x minus 1 when x is greater than equal to 1, right? In that case, this is positive. If x is less than 1, then x minus 1 will be negative. So we take negative of that value. Then it becomes negative of x minus 1, right? When x is less than 1. So that is what you learned in advanced functions. So you have to remember that and apply it here to solve such questions. So that really means that if you are approaching 1, from the right side, you have to take the value of absolute value of x minus 1 as x minus 1. And when you approach it from the left side, you have to take minus of x minus 1. Perfect. So that is that should be very clear, right? So let's say we have to approach x, since we need to find limit when you are approaching 1 from left and right. So when you approach x from the left side, and when you approach 1 from the right side. In that case, we'll be working in two different equations, right? So we are basically approaching this point, right? So what we get here is that the g of x is equal to, when you are approaching from the left side, then this absolute value is minus x minus 1. So I can write this as x times minus of x minus 1, right? Over x minus 1, correct? But when you are approaching it from the right side, then g of x is equal to x times x minus 1 divided by x minus 1. Is that point clear? Now this is the most important step here. Perfect? Okay, now let's move on. Now we can actually cancel x minus 1 and x minus 1. These factors, you are left with g of x equal to minus x here and g of x equal to x when you're approaching from the right side. Clear? So it is absolutely clear from here that the limit when you approach g of x 1 for 1 and from the left side, it should be minus 1, right? So we can now write limit when x approaches 1 from the left side for the function g of x is minus of 1, right? So this is minus 1. On the other hand, limit when x approaches 1 from the right side for the function g of x, then x will be 1, right? So it will be plus 1. So these two limits are different, correct? So what you really find here that the limit when x approaches 1 from the left side for g of x is not equal to the limit when x approaches 1 from the right side. Correct? Since 1 and minus 1 are not equal, right? So that should help you to answer both these questions. So the first one here is to evaluate the limit of g of x when x approaches 1 from the right side. So this limit is 1. And when it approaches from the left side, it is minus 1, correct? So that is what we calculated, correct? And 1 from the right side. Is that clear? Now, then it says, determine whether this limit exists or not, right? So that answer is does not exist. since these two limits are not equal. Is that clear to you? So that is how you're going to answer it. So I hope the concept is absolutely clear. So very less space is left, but we can definitely sketch and do part B also here. So let me just sketch it in this corner. Okay. Since most of the function is positive, I'll draw my x-axis. All my graphs will be rough sketches, but very clear. As you normally do in test paper, right? You don't really get a graph paper to sketch all these graphs. You have to just make a rough sketch. So I'm being really practical. Okay. So what we are given here is that at x equals to 1, the function is 0. So let's say this is x equals to 1, the function is 0. What we found is that g of x is equal to minus x when you are working in the domain x less than 1, right? So it is, so if I put 1 here, I get minus 1 here, right? So I get minus 1. If I put 0, I get 0. So this will be the graph going through the origin. Correct? Now, on the right side, what you notice here is that when x is greater than equal to 1, g of x is equal to x, right? So it is positive 1, but greater than 1. So there is a hole here, right? And then it goes like this. So that becomes the graph of your function. Perfect. So here is your function g of x. Let me write g of x here. This value is 1. This value is 1. This value is minus 1. X on the horizontal x-axis, that is 0. So that is the complete solution of the question you have asked. I hope that helps. Feel free to write your comments and share your views. And if you share my videos with your friends, that would be great. Also, subscribe to them. Thank you and all the best.